Welcome back to Robot Starter Lab. In the previous episode, we successfully established a communication bridge between our virtual simulation and Google Colab using Cloudflare tunnel. Now that the connection is stable, it's time to give our robots eyes. Today, we are implementing a real-time vision pipeline to detect our target object, the red cup. The goal for this episode is simple but critical. I need to process command streams for my local machine in the cloud, identify the cup position, and feed Joe coordinates back into our virtual network. This gives lays the foundation for autonomous navigation, allowing our robot to track its target in real time. However, vision is not one size fits all. In robotics, we have to balance accuracy with performance. To find the best solution, I will be testing three different approaches. Firstly, I use a Grounding DINO. I initially consider Grounding DINO for its semantic power. However, it's a flaw because Grounding DINO requires specific older version of Python and transformation. In my Colab environment, the version config where that's n, I decide to rule it out. It's a powerful tool, but it's best reserved for local setup where you have full control over the environment. If you want to use the Grounding DINO, I recommend you run the local with the strong communication. Okay, next. I look at the YOLOv8. It's excellent for Colab and come pre-trained on many common objects. However, my specific cup has a unique. Looks as the model doesn't recognize. To make it work, I need to collect a custom dataset and label everything. For example, can you collect the image, the red cup, and then label everything? You have the let's go. Yeah, you change vanity and blah blah. Can you the global flow to label, and spend time training a news model. Since my goal is to build this project efficiently, I decide to rule out YOLOv8 as well. It's a great tool, but the time investment for custom training isn't the right fit for this way. Finally, I trained to OpenCV HSV. Unlike AI model, that's a massive dataset. HSV filtering uses color-based logic, but it's incredibly fast, runs perfectly on Colab, and most importantly, it's ready to use right now by filtering the specific red hue of my cup. I guess instant accurate tracking without any training for a project like this pattern of symbol and performance. This is the function they detect a red cup in an image by using color plate segmentation in the HSV color space and return the prouding part information of the detect object. The function receives a single image frame and attempt to locate the red scarf. Open the OpenCV reads image in the BGR color format. By default, the image is converted to HSV separate color information from brightness, making color detection, and it helps more robust under different lighting conditions. Yeah. And see the camera to detect the OpenCV HSV to detect the red scarf and return the position for the local. Can you check in the local? Can you receive note recorded from the Colab? The X equals 170 and Y equal 109 is the same cup center in Google Colab. Thank you so much for watching video, and see you later.